Hi everyone, welcome to this session. So today we will this is a analog discussion session. So today we will solve some basics interview level problems. Okay. So and we will be talking about on- so we will be talking about normally capacitor circuit, cap circuit, and RC circuit. Okay, and the input will be of step current. Okay, step current, step voltage, and pulse. Okay, pulse voltage. There will be some dedicated video like lectures on this topic. So and you can you can think this is a interview question. Okay, not a theoretical session. Okay, so we will see this session as a interview. Okay, so we know that a capacitor is look like this is a symbol. Okay, and if this is the positive terminal of the capacitor and if this is the negative terminal, then we can, and the capacitance value is C farad. So the voltage across these two terminals, okay, this will be like VC. Okay, and what will be the VC equation? And if a current is flowing through this path, okay, let's say let's say I. Okay, it may be constant or may not be constant. Okay, this is a current of I is flowing through it. So what is the equation? So VC is nothing but uh, VC is nothing but let's say 1 by C integration I dt. So this is the voltage equation across a capacitor. We know that, right? Now the main property of a capacitor is basically this cap is a storing element. Okay, storing element. Capacitor and inductor is a storing element. What does it means? It means it can store its previous charges. Okay, or as a form of voltage. Okay, so capacitor stored charges as voltage. Okay, so and another property is, so one is capacitor is a storing element and another is capacitor can hold its previous value. So it like capacitor cannot uh, change cannot change its potential like VC immediately. Okay, immediately or suddenly. Okay, suddenly on condition is the if the current through the capacitor is finite. Okay, so if current through, like if this I is infinite, then this VC can change instantly or immediately or suddenly or abruptly. Okay, so this is the main condition. So what does it means? If VC of minus equal to VC of 0 plus when IC is finite. So we can see that the potential across the capacitor at t equals 0 minus is same as the t equals 0 plus. Okay, when IC is finite. But if IC is infinite, okay, infinite, then this value can change abruptly. Okay, so this is not equal to VC of 0 plus. So this is the condition. Okay, so now let's have some interview level question. Okay, and one thing, to solve this capacitor or inductor problem, there will be some initial conditions. Okay, so if we can say, if a cap is charged at t equals 0 minus is 2 volts. Okay, so let it will look like this, plus minus C, and this is, let 0 minus is 2 volts. Okay, and we are we connecting a voltage source of, let's say this is, this is 5 volts. Then you have to tell what will be the steady state value of this V, let's say V out, and we can make it ground, right? So basically this potential at t equals minus 0 is 2 volts, and this voltage was 0 volt, right? So the Vc is this voltage minus this voltage, so this is 2 volts. So now we have to say what is the voltage across the output at steady state. Okay, so we have to deal with this type of problem. So let do the small simplest one. Okay, so initial condition is very important. So we know that by, like, if we write the formula, Vc of t is nothing but Vc of infinity, uh, Vc of infinity minus Vc of 0 plus minus Vc of infinity whole into e power minus t by tau, where tau is called time constant, right? Time constant of the circuit. Okay, so this is the formula, and this is the unit is volts. So this is the, if there is some initial conditions. Okay, now we can see that if the initial condition is 0, okay, if this is 0, then what will be the equation? We know that this will be nothing but Vc of, okay, this will be plus. Okay, this will be plus. So Vc of infinity is common, and this will be 1 minus e power t by tau. So this is the equation if our initial conditions is 0. Okay, this is volts. So this is the basics, like basic theoretical portion of this capacitor circuit. Okay, now let's have some interview question. So the basic question is this: and on thing we can see that by this equation, actually capacitor is integrating the current flowing through this capacitor. Okay, so whenever there is a capacitor, we can assume, like, if the voltage across the, we are taking the voltage across the capacitor as output, then we can directly say that the capacitor is integrating the input. Okay, so we can see that. 1 minute, yes. So now let this is a current of I, and this is a capacitor C, and let's say Vc of 0 minus is 0 volts. Basically this is initially uncharged. Okay, now we have to predict the voltage output waveforms. Okay, now let's take two cases. Case 1, I is nothing but a constant of, let's say, 2 milliamps. Okay, and second case is I is case 1. Okay, and case 2, and I is a, let's say, pulse. Okay, pulse, let's say pulse is 0 to 2 milliamps. Then what will be the output? We have to predict. Okay, now you will learn, like you have learned, I know you have learned these things. Okay, let this is a step. Okay, and this is t equals 0, and this is t equals infinity. So we know that at t equals 0, the circuit feels infinite frequency. Okay, and at steady state, and this is initial, right, initial condition, and at steady state the circuit feels a frequency of 0, right? We know that. Now we can see that at t equals 0, if the frequency is infinite, then the capacitor acts as a short circuit, right? So at t equals 0, capacitor acts as a short circuit, and at t equals infinity, the frequency is 0, then the capacitor acts as a open circuit. We know that, we know this from the basics. Okay, now for the first case, let's say first case, this case. Okay, What will be the output? This is a constant current, right? Let's say this is I naught, and if this is constant current, Vc will be nothing but I naught by C into T, right? We can see that, right? Because in this equation, if you can put the value as well. Okay, this is a constant, so this is coming out of this integration, and integration of dt nothing but T. So this is the equation. Okay, then we have to draw the waveform, V out waveform with respect to time. Okay, and we know that this is a equation of ramp, so the output will be like this. Okay, so this is the equation. And what is the slope? Slope will be nothing but this I naught by C, I naught by C, and this is nothing but 2 milliamps per the capacitance value, whatever it is. Okay, so this is the first case. And what is the time constant? Time constant. To find time constant, what we do? We do all the independent sources are inactive. Okay, inactive. And then we find the equivalent capacitance of the circuit and find equivalent resistance of the circuit. Then the time constant become R equivalent into C equivalent. This is the time constant. Okay, now for this case, so this is our circuit, right? We know that this is the ideal like independent sources. So for current, like independent source of current, to make it inactive, what we do? This is becomes open circuit, right? So this will be our equivalent circuit to find the time constant. So this is open circuit. So what is the equivalent capacitance here? Equivalent capacitance is nothing but this C only. Okay, and what is the equivalent resistance? If there is no resistance, like this is open circuit, right? So open circuit has infinite resistance, right? So the C equivalent is infinite. So what will be the time constant? Time constant will be C into infinite. So here the time constant is infinite second or millisecond, whatever you say. Okay, so this is how we can find the time constant. Okay, and you can see the from the waveform as well. We can see the waveform is reaching to the infinite voltage. Okay, with respect to time. So there will be no time like time constant in infinity is never reaches steady state. Okay, so this is how we can look at this picture. Now let's take case 2. Okay, case 2 here is this, right? This is, let's say this is t equals 0, this is time period, this is C. Okay, and this is V out, and the initial condition again 0. Okay, of this capacitor. Now this is I versus T. Okay, and this is, let's say, 2 milliamps and 0 amps, 0 milliamps. Now we can see that this. Okay, okay, so up to that, okay, at t equals 0, the capacitor is acting as a short circuit. Then what will be the voltage, like voltage across the capacitor? This will be nothing but 0 by C into T, right, at this point. So the initial value of this voltage is 0. Now it becomes like when it is 2 milliamps. Okay, when it is 2 milliamps, then a constant current is also flowing, but at t equals 0, we know that the frequency is infinity. So the capacitor like can like cannot, like this is a constant current, right? So there is not infinite current. Okay, so the capacitor will charge like previously in this way. Okay, now now so this will be nothing but, let's say 2 milliamps by C into, let's sometime this is T by 2, right? So now, okay, so if I draw the waveform in between this, so this will be like this. So this will be like this. Okay, now now up to that the current source is 0. So if the current source is 0, this will be open circuit, right? So this will be open circuit. Now the capacitor is open circuited, like the constant source is open circuited. Now the capacitor cannot charge in this way and cannot discharge, because there is no discharging path. So then what it does, it will hold its previous value. So the voltage at, like, up to this it will hold up to that value as well. So this will be our T by 2 and this is our T, right? Now for the second cycle, again the capacitor is charged like in this fashion. Okay, and then like this will be up to that point. So this will be that, and here this will be this. So again at this point the current source is again open circuit. So this will hold its previous value. So this will be like this. So we can see that this will be like this. So this waveform is called staircase, right? Staircase waveform. So like if we have a pulse waveform of current with across a, like across a only on capacitor, then the waveform of the V out of, like, voltage across the capacitor will look like this if this is a ground. Okay, so this is how the waveform will look like. Okay, now takes a basic question, like very basics of RC circuit. Okay, now here our V in is V in is V in is a, let's say uh, unit step. Okay, unit step, let's say unit step of on okay, on volts. Now we know that at t, like, we have to find, is there any infinite current? No, right? Because at t equals 0, this becomes short circuit. So this will be look like this at t equals 0, right? So this resistance is making the current through the capacitor is finite, right? So IC at t equals 0 is nothing but V in minus 0 divided by R. So this is a finite value, right? So there is not a sudden jump at this voltage across the capacitor, right? And initial condition of this capacitor is also 0. So at t equals 0, we can see that this voltage output is 0. And t equals infinity, we know that the capacitor is open circuit, right? T equals infinity, capacitor is open circuit. Thus, then the circuit will look like this, right? So this is open circuit, no current is flowing through this path. So this becomes short circuit, right? Like there is no voltage drop across the R. And you can see, you can assume in that way that if the impedance of this capacitor is so large, so the all the voltage drop happens across the capacitor. So then normally V out equal to V in itself. So this will be V out equal to V in. Let's say this is on volts. And we know that the charging of a capacitor is always exponential, right? If there is a finite current, like if there is a not infinite current. So what will be the form? This will be like this. This is the charging of a capacitor. So this is V out and this is T. The charging is always happening in the form of, like, in exponential form. Like if there is a finite current, if there is infinite current, then it can charge instantly or abruptly. Okay, or it can change its voltage across it suddenly. Okay, we know that. And what is the time constant of this circuit? We know that the voltage source, if the voltage source is inactive, what we do? We do short circuit, right? We do short circuit. So if this is short circuit, what will be the C equivalent? C equivalent is nothing but C itself. And what is the R equivalent? This R itself. So time constant is nothing but R and C seconds. Okay. So this is the question. This is the time constant of this circuit. And there is another part of noise. So I am not looking for the noise and the body plot here. Okay. So there will be another dedicated video. And okay, let's solve this problem again. We take, let's say this is t equals 0, let's say 1 volts, this is t equals 0, and this is our time period. Okay, and we are assuming RC is very less than t. And one thing I have to tell that uh, to charge the maximum value of 1 volt like V in, it takes 5 RC time. Okay, so what I mean is, to charge a capacitor fully, it will take 5 RC time. Okay, t equals to 5 RC, so that it can charge to up to 99 point some, I guess 9% of this V in. Okay, of this V in. So this will take 5 RC. Okay, now, and we are taking here. So what does it means? It means that this RC value is like the time constant of this circuit is so small than the time period of this input waveform. Okay, this is our V in. So what will be the charging? So the charging and discharging will be very fast. Like it can charge like very small amount of time. Okay, and it can also discharge the very small amount of time. Okay, so we can see that this is a very small time. But in the previous case, we are seeing that this is taking like this. So this is like very high time, right? In the previous case. Okay, so we are taking that the time constant is very less. Okay, let's say this is our V out, this is our V in of 1 volt. So now at like at this time period, this is t by 2, right? This is t by 2. So during this half time period, what will be the voltage waveform? What will be the, okay, what will be the this voltage V out? So we know that at t equals this point, the capacitor acts as a short circuit. So V out is nothing but 0. But at t equals like this is almost steady state, right? At every time period, this is steady state, and this is like initial, right? This is initial. So at we know that the charging will be happening like in very small amount of time, right? So the charging will be, and there is no infinite current, right? We already said that in the previous case. So charging will be this. Then like at at this point, like at this point, the capacitor is charges to the on voltage. Okay, this is on volt. Now the input is here is 1 volt as well. So the capacitor will charge up to 1 volt, and the waveform will look like this. Like this will reach the V in voltage. This is 1 volt in very quick time. So this will be our waveform at this time period. Now we can see that now at this time period, the voltage is 0. So voltage is 0 means this is short circuit to the ground, right? Now the capacitor is getting a discharging path. Okay, this was previously charged on volt, and this is getting this discharging path through R to the ground. So this will discharge, right? So how it will discharge? this will also discharge in exponential form, because the discharging current is also finite. Okay, so this will be like this, and it will discharge in very small amount of time, right? So this will be this, right? Like it will take this small amount of time discharge, and this will hold, like this will discharge to 0 voltage, and this will remain at 0 volt, right? So at every cycle this form is repeating. So what will be the output of this, like output waveform of this time period, in this time? So this will be again charged up to 1 volt very quickly, and this will be the waveform, and this will again discharge very quickly, and this will this, and again this will charge to this very quickly, and this will discharge very quickly. So this is how the waveform will look like. Okay, now you have to first see the current. Okay, the current of capacitor. If this is finite, then the charging and discharging will be in exponential form. Okay, exponential form. And if the current is infinite or impulse, then the capacitor can change its voltage abruptly, right? Abruptly. Okay, I am showing on example as well. Okay, let this is the circuit. Okay, 1 minute. Eraser is not on. Okay, okay, no matter. Let's say this example. So this 1 volt is nothing but this. Okay, this step of 1 volt. This is V in, this is T. Now what will be the waveform of this V out? V out. We can see that at t equals 0, the capacitor acts as a short circuit, right? And if this is a short circuit, if this is a short circuit, so circuit will look like this, right? Now the what is the resistance of this, what is the equivalent resistance of this circuit? This is nothing but 0. Then the current through the capacitor is nothing but V in divided by 0. So this is infinite, right? So in this case we can see that the current, like the capacitor is charged initially in at 0 volt, right? Initial condition was 0, like this was previously uncharged. So in this case we can see that the capacitor, the current through the capacitor is infinite. So in this case the capacitor can changes the voltage across it immediately or suddenly. So the output waveform will be, this will be reach 1 volt immediately, and this will be like this. So this is our 1 volt. So we can see that the voltage of this capacitor, voltage across the capacitor was 0 initially, and at a sudden time it reaches to 1 voltage. Okay, this is not in exponential form. Okay, it reaches at t equals 0 to the input, like to the, it can change its voltage at t equals 0 like immediately, right? But in the previous case we are seeing that if there is a finite current, the voltage of the voltage across the capacitor was this form, but in this case this can change immediately. Okay, and what is the time constant of this circuit? We know that the capacitor is the voltage source is inactive, so the this will be grounded, and the capacitor is like this. Then what is the equivalent capacitor? This is C. And what is the equivalent resistance? This is 0, right? There is no, like, in this, like, what is the equivalent impedance across this C? This the short circuit path, na? So short circuit path having zero impedance or zero resistance. So the time constant tau equal to t, 0 into C. So this is T, and and we can see the time constant from this from the output waveform as well. We can see that it is taking 0 time to reach the steady state value of V. so the time constant is also 0. So we can find this time constant by seeing the output waveform as well. Okay, so this is the capacitor circuit, and on thing is required. Okay, let me and there is another interview question, very important. So there are two capacitor like this, and the initial condition was given. So this is C, let's say this is C1, this is C2, and they are connected in a switch. Okay, and the switch closes t equals 0 plus. Okay, now there are two initial condition, and we have to find the what is the steady state value of this V out when the switch is closed. Okay, there are this type of question, like the interviewer will ask you, and this type of question I have already solved, so you can see the video, but I am doing right here as well. Okay, so let's say the c1 value. Okay, let's say this is, okay, this is not working. Okay, let me okay, what I was telling that on it. So if this is charged to, let's say this is C voltage, and this is charged to, let's say VC, let's say VC of this 0 was, let's say 1 volt charge, initial condition was 1 volt, and there this is, let's say 2C, this is C and this is 2C. Okay, and this was charged to, let's say 5 volts. Okay, this is VC of 0 for this case, this is charged to 5 volt, and we have to find V out at steady state, and we will try to write the waveform as well. Okay, like what is the steady state, like we can see that there is not there they are not present a resistance. Okay, so we can see that at t equals 0 the current is infinite as the capacitor acts as a short circuit. Okay, let me do that. What will be the value, like what will be the picture at t equals 0 plus? This will be nothing but, and this closes t equal to 0 plus, and we can see that at t equals 0 plus this will look like this. So this is short circuit, right, with a voltage of 1 volt. Let's say this is 1 volt and this is ground, and this is also short circuit capacitor. Okay, so this will be nothing but a voltage source of, like this is shorts with a series voltage of 1 volt. This is the, we can assume in this way as well. Okay, for the initial conditions, so this will be plus minus 5 volts. Okay, so this is the picture. Let's say t equals 0, and immediately as there is not a resistive path here, so the current is infinite, so it will, let's say v out will reach immediately to some voltage. Okay, and how it is possible? So v out is also reaching at, like at t equals 0 at steady state, then the vc1 and vc2 is also reaching, like can change the voltage across it, like suddenly, right? Okay, let's plot. So at t equals 0, let's vc1 was 1 voltage, so let's say this was 1 voltage. Okay, this was 1 voltage, and we can see that at t equals infinity this is a common path, right? So the voltage across this capacitor and this capacitor will same as the v out. Okay, so to find, like here we use like charge conservation law, right? Like initial charge equal final charge, right? Final charge. So what was the initial charges? at t less 0. Let's say t equals 0 minus. What was the initial charges? Initial charges is nothing but q equal to cv, right? So for this cap, this was for this capacitor, this was q was, let's say q1 was c is nothing but c, and q is 1 volts. Okay, and please mind it's the direction of this polarities. Okay, we have to maintain this plus, this minus, and this plus, this minus. If we do this minus, this plus, and this plus, this minus, then the calculation will get corrupted. Okay, so you have to need these polarities. Okay, so this was, let's say, c, and q2 was nothing but 2c into 5 volts, right? So this was 10c. So this, and the total q total was c plus 10c, nothing but 11c, right? This was the initial charge. And what will be the final charge? So final charge will be nothing but, this is the v out, right? So final charge will be, let's say, q final charge will be, this capacitor comes in parallel, right? So the effective capacitance will be c plus 2c, right? And what will be the voltage across it? This will be nothing but v out minus 0 voltage. So this will be nothing but 3c into v out. So these two charges must be equal. So 3c into vo equals 11c. So this c cancels. So v out is nothing but 11 by 3. So this will be nothing but 3.6, right? 3.6 volts, like 3.6 of something, we can approximately assume that. So we can see that it will, the voltage changes at t equals 0 abruptly or suddenly. So the output is reaches 3.6 instantly, and the vc1 reaches 1 volt to 3.6 volts. Okay, 1 volt to 3.6 volts. So this will be the waveform of vc1. And vc2 will be, this was initially 5 volts, so this was 5 volts. Let's say this is 5 volts. Okay, this is 5 volts, and this will immediately reaches 3.6 volts. So this is 3.6 volts. So these are the waveform of, like, three waveforms. So we can find in this way. So this is our v out, 3.6 volts, and vc1 was 1 volt initially, then it reaches instantly to the 3.3 volts, and the vc2 was initially at 5 volts, and then it reaches instantly to the 3.6 volt. So this is how we can analyze the circuit. So is there any doubt?
No, no. Okay.
Okay. So can I stop this session?
Yes.
Okay. Thank you.
Thank you.